Hi again, class. Okay, so I wanted to make a video regarding one of the WebAssign questions for 2.1. This section, I know sometimes throws people off guard because it's just like, what are we doing here? And there are some things you can do to sort of help when you are solving these problems, especially with the graphing calculator. Okay, so first things first, let me show you what we can use to help us with number 3 to see how this is going to appear versus a problem where they give us an equation. So number 3, they don't give us an equation. It says the table shows the position of a motorcyclist after accelerating from rest. So it says after 0, 1, 2, 3, 4, 5, 6 seconds, and this is how many feet they've traveled. Okay, so you can kind of picture again just a motorcycle and it's accelerating, right? It's traveled after 6 seconds, it's gone 238 feet. So the main idea to begin with is they want us just to find the average velocity between these certain time intervals. So first they say from 2 to 4. So all they want us to really do is 2 seconds, and again, it's like feet per second, right? So let me write that, which is like change in y essentially divided by change in x, right? It's like a slope in all of the fancy words. So you can say like y2 minus y1 divided by x2 minus x1. You also could write it as like f of x2 minus f of x1 divided by x2 minus x1, right? These are all just sort of different ways of saying, of representing certain things, depending on what they're actually like talking about, what they're giving you. Okay, so for this one, they want us to go for each time period. They're saying from 2 seconds to 4 seconds. So at 2 seconds, it looks like I am at technically 10.6 feet, and at 4 seconds, I'm at 50.3. So I can just say on my graphing calculator, I can say 50.3 minus 10.6, and then divide it by the change in y. Sorry, change in x, which is just from 2 to 4. It's 2. Okay, so the average of, like, it's just the slope between these 2 points, right? Does that make sense? So I would say like 19.85. And then I'll do it again, but this time from 3 to 4, right? So at 3, it looks like they're at like 23.1 feet. And by 4, again, they were at 50.3. So this time we can say 50.3 minus 23.1. And it tells me between 3 and 4 seconds, they traveled on average 27.2 feet per second. Okay, and then we keep doing this. So between 4 and 5, we can do that, fine. It would be like 100. Oops, if my let me click it. Okay. 109.5 is how far I traveled after 5 seconds. So it seems like I took a pretty good jump in there. Really started accelerating between 4 and 5 seconds. And then lastly, between 4 and 6 seconds. So I'm going to go ahead and say 238.3 minus 50.3. And I'm going to go ahead and divide by 2. Because again, that time I went from 4 to 6, so that was a change in 2. So I was going on average 94 feet per second between 4 and 6 seconds. Okay, but then it says plot the points in the table to create a graph of s as a function of t to estimate the instantaneous velocity in feet per second when t equals 3. Round your answer. Where is it at? Round your answer to 1 decimal place. Okay, so this one could have been posed some problems depending on a number of things. It's a little bit odd, right? So depending on like what kind of plot are you looking for, right? Do you want me to plot it like by hand? Do you want me to plot it on my graphing calculator? I have my graphing calculator, so I think I'm just going to do that. Okay, I'm just going to put it into my graphing calculator. Again, I know it's a little random. So what I'm going to do is I'm going to go stat edit. We don't typically have that much to do with this, but like, why not? It's fine. So it says to plot the points in the table to create a graph of the function s as a function of t to estimate the instantaneous velocity at t equals 3. So they want us to actually plot the points in this table, the original table, to create a graph. Okay, and then we can use that to just sort of estimate the instantaneous velocity at time t equals 3. There's a lot going on there that can sort of make this sort of a little tricky. So let's see what we can do here. So let's go ahead and put in, I already have some data in my table from I don't even know when. It could be anytime. So let's go ahead and clear that out. So I'm just going to go ahead and go up to L2 and I can click clear and it can kind of wipe it out. That might be helpful. And I'm just going to leave 0, 1, 2, 3, 4, 5, 6, but you can just enter in 0, 1, 2, 3, 4, 5, 6 into L1. And then we'll go ahead and go over to L2. And we'll type our data in there. So 0, 0 was the first point, 4.1, 4.9, 2, 10.6. So while I'm typing this in, just a little note, a lot of us are application-based STEM majors, right? There are a few who are thinking about being maybe a math major, which is still in the STEM career. But a lot of us are also going to be focusing more on like how to apply this math, right? So one of the biggest concepts that we want to make sure we definitely nail in this lovely class is that we have to understand the relationship between distance and velocity and acceleration. Okay, so we are talking about right now like the distance traveled. So hopefully it makes sense that if we're talking about like the slope essentially between these points, talking about like the average velocity. We are working towards developing using limits. At the end of the chapter, we're going to be able to come up with an equation for the instantaneous velocity. And then again, the relationship between how to go from distance to velocity to acceleration and then back is key. Okay, is key to this class. But for now, we'll just, again, focus on what we need to, which is just trying to get this into our graphing calculator. So I went ahead and put the data in. I'm also going to do zoom stat, I don't know, just to kind of see. Oh, I think I have some old data in there. Let me go ahead and clear that out to make sure I can see all my points clear out. And also, sorry, I think I forgot to turn on the plot. That would be helpful. Let me turn the plot on. So that would be good. So that when I turn the plot on, that you go to y equals, and then you push enter on plot 1, that'll just make sure that whatever you have in the list is actually plotted, which would be somewhat helpful. Okay, so once we have a graph-ish of this. I did it. I plotted the points in the table to create a graph, and now they want me to actually quote calculate the instantaneous velocity. Sorry, when t equals 3. So there's you could do a few different things. Like you could we're talking about 0, 1, 2, 3 seconds is right in here. And they just want us to estimate it. So you could try to in theory, sketch a line, right? Or actually, sorry, it wouldn't be a line. It would be like a lovely curve. It looks almost like it's growing. It's some kind of power, right? So it could be a quadratic. We don't really know. It could even possibly we don't have enough information. Okay, but again, they just want us to estimate it. So the best way that we know how to estimate at this point in time is just to pick some points like on either side. Okay, so you can just sort of roughly estimate here is what we're looking for. Like, what is the slope of that line? I don't know. You could let me clear that one. That last line went a little off the rails. You could go ahead and draw this again. If you had like a piece of paper, you could just take a pencil out and try to sketch a line and see where it gets you, right? You can also just sort of ballpark. So we know, for instance, that, let me get this a little smaller. This comes up again a little bit later, like this idea of just kind of taking a sketch and trying to get something from it. So the point 3 is at 23.1. Okay, that's the y value here is 23.1. Okay, I'm just going to try to draw on my calculator screen with my lovely pen here. And then we also know that at 2, it's at 10.6. Okay, so 2 is 10.6. And if we were to try to connect these lines together, boop, 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 I think it's going to be a little bit more than what we would have if we just focused on whatever the change was from 2 to 3 seconds. Okay, a little bit more. And again, I'm just ballparking. So this sometimes people don't love this, okay, because it's what do you even mean? I'm just roughly guessing that it looked like it was close to, if I just connected essentially these points together, 23.1 minus 10.6, but a little steeper than that. So it looks like roughly 23.1 minus 10.6 is like 12.5. And we just want to try to give a good rough estimate that looks to be a little bit steeper than that. I don't think it's nearly as steep as what it was when it was like from 3 to 4. It didn't seem like it really like started really accelerating that much yet. But it is either you're clearly getting faster in your motorcycle, right? So to give you an idea, to find like if we just connected 3 to 4, that would be 50.3 minus 23.1. And that was 27.2. So definitely not as high as 27.2, right? But maybe like somewhere roughly in between there, we could even talk about. So 27.2, I'm just going to find the middle number between these and then use that to kind of give me a rough estimate. Again, you don't, it's sort of just a complete estimate. So we could say like 19.9 if we wanted to try that. There's these are, I know, uncomfortable because we're just getting a rough estimate, and WebAssign allows for a large error of room of things that they could accept. So I think you could put anything in there from like 16 up to like I put 19.9. It's just sort of like making sure you sort of understand just eyeballing really what we think this could possibly be, and then lo and behold, we'll come back later and be like, oh, we can actually figure this out. Isn't that great? Okay, so again, I get why that one is number 3, part B is particularly tricky. If you look at like how they explain it or something like that, their number could be different than what you got. Again, it's just any sort of, I think if there's a wide range of estimates that they will accept. If they do not accept your estimate and you kind of want to know why, let me know, because I'm thinking, again, we're just going off of this random graph that we have after we plotted the points, and we're just trying to eyeball it and be like, well, okay, it looks like a little steeper than the line between 2 and 3, but not as steep as the line between 3 and 4. Let me take the average of that and see what happens. That works. There's actually like a lot of different ways to try it. The other thing I want to make sure that we talked about is something like number 4, where it says a graphing calculator is recommended. They give you this really ugly equation. Okay, so I'm going to go ahead and type this into my graphing calculator again and see. I already clicked like submit for testing, so we can always go ahead and clear that out. If you see the little X's, just ignore those. So it says the displacement of a particle S moving back and forth along a straight line is given by this equation. So I'm going to go ahead and type this into my graphing calculator. So I'm going to say 2 times sine of pi times x plus 5 cosine of pi times x. I think that's pretty much everything. Also, I'm just going to double check to make sure that my graphing calculator is in radians and not degrees, because I believe they are just focusing on radians for now, and that is usually the standard, especially if there's a pi in there. That's what we're going to be looking for. Okay, so that's great. We have a lovely equation. Let me go ahead now. I can turn my stat plot off that I turned on before to get those points on there. Once the snake is done drawing here, but it's talking about again the displacement of and it's going back and forth, so that's why it's kind of going like above the x-axis and then below the x-axis. It's going positive and negative because it's going back and forth. Okay, so it does, however, ask to find the average velocity between these points, and that is an ugly number. So what's the best way to do that? So I'm going to give you, there are a bunch of different ways, but I'm going to give you what I sometimes people maybe don't really recognize as an option. And again, if you have a different way of using graphing calculator, go for it. But something that people often forget about is there's this vars button in our graphing calculator. So after we put in the equation into y equals, if we go to vars and we go over to y vars and we push the function, we are only dealing with Y1 for right now. We can have the graphing calculator evaluate it for us like multiple times. Okay, so I'm gonna to start out with, I'm going to vars, going over to Y vars, and I'm putting parentheses 2 minus, and I did it again, vars, Y vars, function y1 parentheses 1. And so what this is going to do is it's going to plug in 2, It's going to plug in 1, right? And then I'm going to find out what I have here. This is going to be like y2 minus y1, and then I can divide by what's the difference between 2 minus 1. Oh, I can do that myself. That's just 1. Okay, so 10 divided by 1 is just 10. Okay, and then I can do it again. If you have a somewhat updated graphic calculator, I know I never had this option. So if you don't, it's okay as well. You can scroll up using the arrow keys in your graphing calculator and you can recall what you just did. This can sometimes be helpful if you don't want to feel like going to the y-vars situation again. You can also click second insert. This allows you to, as it sounds like, insert a number. So for instance, if I had first had 2 in and I wanted to put in 1.1 and I didn't feel like when when you graphing calculator, you just kind of it types over top of it and it messes it up the formatting a little bit. You can hit second insert and that'll get me what I would have if I had 1.1, take away 1. Now this is, again, we're starting to get a little uglier because I think I dipped down below the x axis. Now I do have to also divide by x2 minus x1. Okay, because remember, I'm just finding the slope. Change in y divided by change in x. So 1 minus 1.1, I'm just going to divide by 0.1. That is something that sometimes people forget about, is that they actually do have to divide by the change in x, especially if they do it kind of this way. What is 2 decimal places? Okay, that's fine. All right, and then I can do this again. I can go up and I can recall the answer that I had used before. I had y1 of 1.1. Now I want to go ahead and do 1.01. I'll do second insert 0, 1. I don't want 0, 1, 1, so I'm going to delete that one. Y1 of 1.01 minus y1 of 1, I get negative 0.06, and I'm going to go ahead and divide by the change in x, which is 0.01. So this is just like a very fancy way of essentially just finding the slope between 2 points when they are particularly bad or are ugly numbers. This is what I would recommend you do. Is to think about using y-vars. Another option that people sometimes use is sort of like more of a combination of the graphing calculator and finding it by quote hand. It's not really by hand, but let me get this off here. I think sometimes it gets a little frozen. That's the only problem with my graphing calculator on the computer. Okay, I had to restart the application, but that's okay. So we are back on the graph now, and I'm going to show you a different way you can do calculate the slope between these 2 points without using vars and y-vars. So there are some other things we can do when we hit second calc. And we do that, we see value, 0, minimum, maximum, intersect, dy dx, and the integral of f of x dx. So if we ever need an estimate of the derivative or integral, keep in mind, they are here. They are hanging out. Okay, so I hit value because what I'm going to go ahead and do is I just want them to tell me it's the same thing as just plugging these numbers in by hand and having the graphing calculator give you the lovely big number. Okay, so if the y-vars was a little too confusing for you, that's okay. This is just the slope between 2 points. So at the end here, we have like y2, so y of 1.001, which was negative 5.00. Fix my pen. Okay. Whew, this feels bumpy. 5.006 minus what we would get if we plugged in 1. So we can do that as well. We do second calc 0 and we just plug in 1. If we had done this for all of the other from parts 1, 2, and 3, we already would have had this, right? That would have been okay. So I'm going to plug in minus -5, and then we have like 1.001 minus 1. So this is just an alternate way. There's so many ways to use the graphing calculator, really. you might even have a better way than what I have right here, to find the slope between 2 points that have a lot of decimals, essentially, is all we're doing here. So if you need any help with the VARS or the YVARS options, definitely let me know. Okay, we can definitely spend some time talking about it. Okay, it says two decimal places. So I'm going to say -6.26. And this says estimate the instantaneous velocity. Well, we've just been getting closer and closer to what the actual instantaneous velocity. So I'm just going to go ahead and say -6.26 because that is the closest we have. We could technically have taken this even farther out. Okay, we could have said, okay, try it again. Between 1 and 1.0001, and between 1 and 1.00001, right? The whole idea is that we're trying to find the slope between 2 points, and they're getting closer and closer and closer together, and they're going to be really ugly. Okay, it's going to be gross. It's going to have a lot of decimals, and then lo and behold, here comes calculus to save the day. And actually, it doesn't have to be that bad. We can calculate we can find the exact value, and all we have to do is bust out some limits. Okay. So I hope this was maybe somewhat helpful for you. I know we first talked about number three, especially part B, caused some issues. And again, they accept a wide range of answers. So I understand if it's a little like, I don't know. And then also how you could possibly use your graphing calculator to calculate some of these bad values. You can use vars and yvars. You can also just use like enter into y equals, and use the value button in the calculator. I've also seen students who just prefer to use the table of values because you can always reset the table of values to start. If you hit second window, you can start wherever you want. So you can start at 1, I don't know, you can count by 0.001. There's just so many options really, of how we can use our graphing calculator to help us, just to kind of compound some of these numbers, in the quickest, most efficient way. So it's up to you. What you want to do. If you have any questions, please let me know. Again, this is from 2.1. And once we get through this part with the graphing calculator, we dive right into limits. Where we get into some weird algebra like with infinity and things kind of go into the infinity calculus range versus here where we're just talking about like finding good estimates or finding better estimates. So I know sometimes this section throws people off a little bit, but please keep me posted, and I look forward to hearing from you.